One possibility for increasing the initial compromise rate or designing a very fast-spreading worm is to create a hit list, or a list of vulnerable hosts ahead of time. That curve we just saw shows that the time to infect the first 10,000 hosts dominates infection time. So if we start by performing stealthy scans or some reconnaissance to construct a list of vulnerable hosts before we start spreading, then we can get rid of that initial flat part of the curve where the worm is effectively dormant. The second approach is to use something called permutation scanning, where every compromised host has a shared permutation of an IP address list to scan for vulnerabilities. Now, if this list is randomly permuted and a particular host starts scanning from its own IP address in the list and works down, then different infected hosts will start scanning from different parts of this list, ensuring that compromised hosts don't duplicate each other's work. One worm that exploited these techniques to spread particularly quickly was the Slammer worm, which spread in January of 2003, exploiting a buffer overflow in Microsoft's SQL server. In addition to using fast scanning techniques, the entire Slammer code fit in a single small UDP packet. The UDP packet contained the worm binary followed by an overflow pointer back to itself. It was a classic buffer overflow combined with random scanning. Once the control was passed to the worm code, it randomly generated IP addresses and attempted to send a copy of itself to port 1434 on other hosts. One brilliant aspect of the Slammer worm is that because it was spread via a single UDP packet, it was connectionless, meaning that it could spread and was no longer limited by the latency of network round-trip time, but only by the bandwidth of the network. The worm caused $1.2 billion in damage and temporarily knocked out many elements of critical infrastructure, including Bank of America's ATM network, an entire cell phone network in South Korea, and 5 root DNS servers, as well as Continental Airlines' ticket processing software. The worm actually did not have a malicious payload, but the bandwidth exhaustion on the network caused resource exhaustion on the infected machines. Here is a picture of the hosts around the world that Slammer infected. This damage was inflicted in just 30 minutes due to the very lightweight nature in which Slammer spread.